Good morning,
For the
everyone. Today
augmented reality.
we are going to look on computing
We know
architectures
that
of
augmented
VR.
reality is
How the
well versed
computing
in today's
architectures
world,
is used in
especially
the
in
virtual
the
reality.
field it is
So
used
when
in
we
the
see,
gaming and entertainment.
when if we want to see in more detail, before we'll have a recap
So
of how
here
the
we
virtual
have the
reality is used
advantages
in the
of
immersive
the
computing
AR, that is
architectures,
the
rendering
augmented
pipelines, and
reality.
also in
So
low
when we take
latency
the
with the help of
advantages,
the word-based
it is mainly used for the
architectures.
learning. It is very
So
much
let's
useful
see
for the
what are
form of
the
the
overview
understanding
of a
basis,
virtual
and
reality
it also
system and how it is
improves the
used is
user
also very much
engagement.
important.
Yes, it is
So when
well versed
we
in
look into it,
improving
we
the
have an
user's
input and a
engagement,
processing
and
and also the output. This is
mainly
how
it
the virtual
reduces the
reality goes
errors
on. So
in
it
the
has some
industry
key
based.
components like
So
the input devices, it
when we
has a
have a
computing
small or
unit
a tiny
and a rendering
human
engine,
errors,
and
all those
finally it
errors
will
will
have
be
a output
detected,
device
or
with
there
the
won't be any
HMD
error
audio
from
and
the
haptics. See, if you look
previous
into
time
this
itself.
picture, this
So
is the
and
help
also it
of
is
an
very cost
architecture
effective training,
design.
where we can use
So
it in
the
our
team leader
own
is
mobile,
showing how the architecture
and we
design
can
will
have the
be. With the
experience
help
of
of the VR,
augmented
we can
reality.
able to view the
So
reality of the
there are also
picture
few
in the form of
limitations
sensors
that
and
is to be
trackers.
followed. How
When do we have a
the
computing architectural
device
in a
is
high
being
level? It
dependency,
will have an
and
input
only in limited
subsystem
field
and a
of
processing
view we can able
subsystem
to
and the output
it can
subsystem.
able to capture
So
and
in
we
the
can view
input
it,
subsystem, the
and
head
also
tracking,
there are a
whatever
lot
we
of
are using
performance
it, okay,
issues,
the
and
movements that is
battery
done during
issues
the
also
head, okay,
one of the
during
limitation
the
in the
movement of the head,
augmented
hand
reality.
trackings, the
Okay,
fingers, the
so
hands, okay,
it's very
and the
usual
gestures, how
in
we
the future
walk, how
scope,
we run, all
where
those things,
definitely in
everything,
future
how we sit,
the
okay,
augmented reality
everything is
will be
done in the
well
form of an
versed
input
in the
subsystem. Then
AI
we will
powered,
process those
and
trackings
also
and
in
how it is
those
done, okay.
experiences, and
Those
mainly in
trackings are done with
education
the
base.
help of a
It will be
CPU
definitely
or
useful in the
GPU
smart
or a
classrooms. So
coordination
hope
and
you
whatever.
all
And
understood.
here we have
Here
the
is the case
output
study where we go through
subsystem
how
also,
this
which gives the
augmented
visual
reality
and
works
the
in the
audio and also the
in
haptic
manually
feedback,
doing
the
a
real-time
repair. If
interaction,
suppose a
which is
repair is
very
caused,
critical
how
more
does
enough.
this
So these are the
it
things which
troubleshoot,
is
and how
done in
does
the
it makes it
architectural form with
fast,
the
and
high
do all
level
the
formation.
tech go
We
through it.
have a
So
VR
hope you all
hardware
understood.
architecture
Thank you.
which has a CPU, a GPU, and the sensors. The CPU will have a scene management with the physics and also the AI logic. All those things can be used. Whereas when we take the sensors, the accelerometer sensor, the camera sensor, crypto like scope sensors, all those sensors is very important for a virtual reality. When we have a head mounted display, definitely it should have a stereo display, because the display should be more clear enough, and also the audio that we are hearing, it should be a stereo display with a low latency, which is more important. So first we were looking into the hardware architecture. Now we are going to a software architecture. So the hardware is what we see. The software is what we apply or what we develop. So the software architecture of a virtual reality should have an application layer with the engines that are used in the middleware, and what are the graphics memories or graphic APIs are used during these visualization, and the drivers, okay, the device drivers that is more useful and interface with the sensors and the displays. So this way it is actually used with the software architectures. So what are the types of VR computing, and how it is actually used is, first is the standalone virtual reality, and it as a PC based virtual reality with a high performance a PC based distributed virtual reality system and a cloud based virtual reality. So when it comes to a standalone, the device that we are using on the before the eyes. See, look at the picture. There's a girl who's all calculating the stocks in an industry, how much stocks is available, what has been arrived. All those details are done with the help of this virtual reality, and what all the things is which is inside, all the stock products are correct or not, where any damage takes place, all those things can be done with the help of this virtual reality. Whereas the PC based VR also, where it gives the high performance of GPU rendering, and it has a few distributed systems with the cloud based where it is stored. The next is we are going to introduce the rendering principle. Okay, the rendering principle is more important. That is, it converts the 3D scene to the 2D image. It also has few goals like realism, and it should be a low latency and a high frame rate, and it should have a stereo rendering for depth perception. So in that way we can able to head tracking, the finger tracking, all those fully immersive virtual display will be done with the help of few rendering principles to be followed. So these are the few rendering pipelines which is more important. There are lots of rendering principles, and one of the rendering principle is VR rendering pipeline. So the pipeline is more important because the scene modeling, the geometry processing, the view transformations, lighting, shading, and what all the object space is needed, and rasterizations, and how the output should be with the left eye and right eye, the fingers that we use, and the decoding, rendering, all those will be done in the form of a pipeline. That is the step-by-step process. We also have a case study for the rendering principle. Here the rendering principle is applied for separate images for left eye and right eye. So what are the images can be seen in the left eye, and what are the images can be seen in the right eye. So this should have a smooth experience, and how the outcome will be is through immersive experience without external PC, it reduce as usual low latency, and it should be a motion sickness where the motions should not be blurred or it should not buffer, and it should have an efficient balance of performing, and the power is also more important. So hope you all understood how a hardware architecture, a software architecture is used to complete the VR. Hope you all understood. Thank you.